Cool. So to kick off, we're going to look at alert dialogs with this screen. The context for the alert dialog is deciding whether you want to delete the to-do that you've clicked on. So imagining that this is a to-do, we are going to decide whether we want to delete this or not. We're not going to do the actual deleting functionality, as in deleting it from the data store, because if you can remember from last week, we didn't necessarily actually create a to-do. We just incremented a counter for demonstration purposes. But what we will achieve is showing a dialog with yes, no options for do you want to delete. If the user presses no, the dialog just gets dismissed and they can still interact with the screen. But if they press yes, the dialog will dismiss and this screen will automatically disappear. It will automatically go back, insinuating that the to-do has actually been deleted. And where we're going to trigger the to-do from is this floating action button. So I've just stuck a cross icon in here. So when we press this, a alert dialog will pop up. And let's take a look at how we do that right now. I'm just going to shove that down so there's less stuff going on. But if we look at our floating action button down here, you can see I've specified the icon, which is a close icon, and it's even showing us a little preview there. And we've specified an onPressed function, which gets called each time we press this. So I will actually need to bring my debug console up for this, but right now, as I press it, nothing happens, but we can just add a print statement in here to demonstrate that. So hot reload has reloaded the code in less than 400 milliseconds, which is really fast. So now when I click, we can see that this function is being called, which is good. So the next thing we need to do is show an alert dialog. And there's a couple methods that are helpful for this. I say they're helpful, they're actually fundamental to this. So Flutter out of the box has loads of different types of things you can show. So I've typed in the word show, and IntelliSense has come up with all of the things that it's only really these top few that are relevant, but loads of different things that I can show. And these are for loads of different circumstances. So we've got show about dialog, show bottom sheet, Cupertino dialog, Cupertino modal pop-up, and there's a few others such as date pickers and bottom, and then searches and menus and stuff. So these are all different ways of showing UI elements, and these generally have different animations with them. That's typically the main thing that changes between them, and I'll demonstrate that shortly. But the two methods that we need to, the two functions here that we need to worry about are show Cupertino dialog and just show dialog. These two do pretty much exactly the same thing. The only difference is the way that they actually show the dialog. And what I mean by that is the way they animate the dialog in. That will become a bit more obvious later when I actually start demonstrating this, but before we get to that stage, we kind of need to get a dialog to show to start with. And because I'm running on an iOS simulator, I'm going to start with Cupertino, but we will be switching between showing a material one and a very iOS looking one. So this show Cupertino dialog function is going to run every time we press this button, but it requires a few parameters first, or arguments, sorry. These are named parameters on the method. So context and builder, and these are ones which this method absolutely requires. Context, if we see, is the type is a build context. And last week I mentioned how a build context contains information about where the current widget is in the widget tree. Just quickly, last week I showed this slide, which demonstrates the kind of tree nature of Flutter. So a build context for center knows that there's a body above it. Body knows that there's a scaffold above it. Scaffold knows that material app is above it. Text knows that center's above it, which knows that body's above it, etc., etc. That's how this function, show Cupertino dialog, is gonna is going to be able to know where within the widget tree to show the dialog, to add the dialog. So we can just pass in our context here. We're going to see the word context in quite a few different places in a sec, but don't worry, I'll briefly touch over them, and there's some of them that you don't need to worry about. This builder parameter for show Cupertino dialog, its type looks kind of funny if you're not familiar with the Dart kind of syntax for this, but builder is a function which has a parameter which is a build context type, and the function returns a widget. So here we can specify an anonymous function called build context and give it a name. It's okay to call this context as well, because the function body is now a different scope to this. So it's now a different scope to the context we've got up here. There are circumstances where you might have quite a lot of methods which have a parameter of context, and they could well be nested. So it actually gets quite annoying having to remember to change them to context 2, context 3, etc. But it actually doesn't matter if they are called context. So I'm going to leave it as context for now. And I'm also going to do away with the type here, just because Dart is a strongly typed language and it infers it just fine. This builder function is how we're going to show Cupertino dialog what widget to show. And it just wants a widget. It doesn't have to be a dialog widget. It makes sense to be a dialog widget, but it can be whatever widget we want it to. It can be text. It can be a scaffold. If you really wanted to show another screen, I wouldn't recommend it, and it would probably look strange. But it can show any kind of widget. And I'm going to demonstrate that with showing some text. This is going to look incredibly strange, and that's because it's really not supposed to have it. You know, you wouldn't really just show some text. But this is what happens when I now press this floating action button. Look out for the animation. It might look a bit jerky, and it might not even be visible in screen share. Hopefully it just is, but you'll see some text appear in this top left corner. And the way it animates in will look like how an iPhone dialog animates in. So it's quite subtle, but it kind of came in as if it's coming in from your viewport, as if it's kind of coming down from you. And what this method has done is added this widget, this text, to a overlay kind of navigation stack. So it's created an overlay, but added it to the same navigation stack. Much how we were able to navigate between screens using a navigator, Show Cupertino dialog also uses a navigator to add this widget. Rather than swiping along and showing this, it adds it to the top. So you can kind of think of a dialog as being part of the same navigation stack as screens as well. And that's going to become important to know in a sec. Cool, so now let's start to make this look a bit more visual. All I've done is show some text, and it's actually not looking at all right. What we need to do is kind of return the widgets which make most sense. So I'll keep this text because we will need the text. But the main thing we want to return is a Cupertino dialog. And this is very appropriately named for the very appropriate use case. I'm on a beta version of Flutter just because I'm playing around with some web stuff. So that looks to be deprecated. But the one I actually want is Cupertino alert dialog. That's the one I meant to type in, and that's the one I typically always use. So Cupertino alert dialog is a widget which is going to look a lot more like an alerts dialog. If we look at what named parameters it asks for a title, some content, and some actions. Those are the things that we're going to worry about. So we're not going to worry about the scroll controllers and animation stuff, although we are able to control the animation, but we don't necessarily need to. So we can specify the title, and we'll give that some text. We can also specify the content, and we'll make this some text. So now what's going to happen when we click this floating action button, we're now going to see we are going to see an alert dialog. Before we do that though, I've actually really screwed myself up by just showing some text. Because what's gone on here, show Cupertino dialog has added this text to the navigation stack, but it's blocked me from interacting with anything else. So right now, I cannot click anywhere to dismiss this alert dialog, which is actually some text. So I'm not going to be able to click this to re-trigger anything. I'm going to need to hot restart. But, how do you get that to go away? Oh, there we are. But that's okay, because hot restart is still blazingly fast. It's already done. I didn't have to stop and start recompiling, which is really cool. So now when I press this floating action button, there we are. I've got a very iOS looking alert dialog, which is great. The next thing we need to do is add some buttons, because by default, we also can't actually just click anywhere to dismiss dialogs. On Android, you can, and there's a very subtle difference between show Cupertino dialog and just show regular dialog. And I'll touch on that in a sec. But yeah, right now we need some actions to allow ourselves to dismiss this alert dialog. So actions are going to be those buttons which you see as attached to an alert dialog. And again, this is an array of widgets, so we can actually use any type of widget we want. Just to demonstrate that, and probably also to demonstrate why you shouldn't necessarily, I'm just going to use some texts here. I haven't actually done this in testing, so I'm also slightly intrigued to see what's going to happen. It's done it. It's added them to the right places. It doesn't look right, but it is possible. It is possible to do. The reason we're getting these yellow underline squiggles is to do with the text not really knowing it. In our main app, we specify some text themes, but at the moment this is overlaid in a way that it isn't able to access the default text styles. So that's why this text looks quite strange. But that's rectified when we use the proper widgets, which we should be using. So the proper widgets are Cupertino dialog action. So these are the right widgets we should be using. So here we can stick in our texts for no and our texts for yes. So now when we show the alert dialog, we get no and we get yes. And this looks very iOS. You would be hard pressed to tell that this isn't, using Swift and showing an, what you might consider a very native alert dialog. So yeah, cool. Now we need to make these buttons dismiss the dialog. And these Cupertino dialog actions have a way to do that. They have a onPressed parameter. It's a named one again. That's why we have to type onPressed. And these can just be anonymous functions as well. So let me just create the two here. Cool. Let's start with a no. So what's going to happen is when we press no, we want to remove this alert dialog from the navigation stack. When we add something to the navigation stack, such as pushing a route to the navigation stack, I may have given the game away a little bit. I was going to ask the question, if we push something to the navigation stack, keywords there being push and stack, how would we remove something from the navigation stack? Can anyone think what the method might be, or what the keyword we'll use might be?
Pop.
Pop is correct, yes. Well done. So what we're going to do is we're going to use a similar method to what we used last week to find the current navigator for our app. So navigator exists deep down in our app somewhere. And this method looks up the widget tree to find the one responsible for our app. And last week we used the push named method on this with /task. And that would add a new screen to the navigation stack. But what we want to do is pop the navigation stack, and that will remove the thing that's currently on top of the navigation stack, which is our alerts dialog. So let's demonstrate that. This shows it. And also, because I've now actually specified onPressed in these dialog actions, although the yes one doesn't do anything, because it's been specified, the text is now blue, insinuating that it is very clickable. And when I press yes, nothing's going to happen. But when I press no, it's going to dismiss itself, which is the expected action, which is great. Cool. We can then copy that to yes as well. Cool. So now whenever we press any of these, it dismisses itself, which is great. If we think back to the scenario that we're doing this in, we're asking, are you sure you want to delete? And you press yes, you would expect it to look like something has deleted. So you would actually expect this dialog to be dismissed, which we're doing. You'd then also expect this screen to be dismissed automatically as well. There's two ways you can achieve this. Well, I'm sure there's loads of ways you can achieve this. There's one obvious way you can achieve it, which I'm going to demonstrate, but then I'm going to show you the better way this should be done. We could actually pop the navigation stack twice when we press yes, if we really wanted to. So we'll come here. No just does it the once, so it only dismisses the dialog. But when we press yes, it dismisses it twice. So it does return back here, which appears like it's doing what we want. But there's a neater way. I'm going to show you guys a better way to show you how to do this. Before I do that, does anyone have any questions at this stage around dialogs or around the sticking widgets wherever? Cool. In that case, I shall move on. So when using alerts dialogs or any kind of dialogs, it makes sense to understand what the user has pressed and perform actions on that, or get an object back based on what the user has pressed. So for example, if I said no, that's kind of insinuating no, do not go and delete this. Whereas if I press yes, it's insinuating yes, do go and delete it. What it makes most sense to do is to have the delete logic as part of this. Well, it kind of depends how else you've architectured your data model and your business logic and stuff. But really, it doesn't make sense for this direct button to be responsible for doing all of that deletion logic. Really, it should actually just be telling me whether the user pressed yes or no. So what we're going to do is we're going to pass a value back to this method here on pressed, because show Cupertino dialog can actually return a value. So we can use show Cupertino dialog to ask the user, do they want to delete yes or no, and store whether they said yes or no in a variable and decide whether to delete or not. So that might look like var delete equals false. So a Boolean representation. If we should delete, oh, that didn't look right. If delete, then do the business logic to delete, and then once it's done, dismiss the screen. This is essentially what we're going to be This is essentially what we're going to be doing, but we're going to understand whether we should delete or not based on which action you pressed. And I'm going to do this a little bit in reverse. So this pop method here has an optional argument called result. And what this insinuates you can do is, if you've navigated to a screen, you can return an object back to the screen that you navigated to. So that might be, for example, if you were adding a new contact, it would take you to the add new contact screen. When you're done with that, it would send the new contact back to the screen you're on so you can start using it. It's a similar kind of thing we can do here. We can return an object to where we called this method, show Cupertino dialog. And it can be any object we want. For us, it makes most sense to return a Boolean of false for no and true for yes. So what we want to be achieving is this. Assigning, I'll come back to that in a sec. We want to assign the value either true or false to this variable here and then take action on it. So we're telling show Cupertino dialog that true or false has been pressed. But we don't want to actually block our UI from doing this, because someone could click the floating action button and then just leave the app running for like 5 minutes before doing anything. There might be some animations going on in the background, or other stuff might need to go on. So we don't want to block operation completely. But equally, we do still need to only perform something when they've pressed yes or no. And for that, we can use Dart's async and await syntax. That makes it really useful for stopping where we are in the code until a value has been selected, but it kind of waits for that in the background and still lets everything else perform. It just makes it really easy for us to pause where we are in our method and wait until something has actually happened. The best way to describe this, if you're not familiar with async and await syntax, is actually to demonstrate a very simple print statement. What I've done here is I've called show Cupertino dialog and immediately after said, print something to the console. So now when I press this, hello gets printed straight away. But what we actually want to do is wait until a value has been returned from show Cupertino dialog. And to do that, we need to use the await keyword, which waits until this has got something to return. In order to do that, though, the function we're calling this in needs the async keyword. Now what happens is whenever I press this button, this method gets fired, and this line of code here doesn't run until show Cupertino dialog says, okay, yeah, you can now continue. So when I press this, you'll now see that actually hello wasn't printed straight away. When I press no, it now is. So we're able to kind of stop where our code from executing until we have a value back, which is really cool. And we can assign this value back to a variable called delete. So now we can see the value that's been returned. So clicking here, nothing's been printed yet, but I'm now going to press no, and false gets printed to the console. Here, when I press yes, true gets printed to the console. So that's how we can wait for user input in the context of a dialog, which is really cool. So we can now do some logic based on whether they've said to delete or not. If so, then logic to delete to do. And then once it's done that, we can then now just return to the last screen. We don't need to return an object. We can just pop and it will go back to the screen. But if I say no, this block of code isn't going to get executed. So let's demonstrate that. I've shown the floating, I've clicked the floating action button and I press no on the alert dialog and nothing's happened, which is great. When I press yes, it has run this block of code and it's gone back, which is really cool. So yeah, that's how you can wait for users to interact with your dialogs in order to determine whether they actually do different actions. Before I move on to showing either an iOS or a material looking one, does anyone have any questions at this stage? Cool.
Good. Just such a good introduction, Tom, that no questions have surfaced.
Cool, thank you. Yeah, so yeah, because I can only see up to 6 heads on my side monitor, so it's a lot harder than doing this in person, being able to scan the room. Yeah, cool. Yeah, please do shout if you do have questions. Cool, so the next thing that we want to do is to determine whether we should show a Cupertino dialog or show a material looking dialog based on whether this is running on an iPhone or running on Android. To do that, we're going to separate that part, that deciding whether it's running on iOS or Android and showing the different dialog or not, to a different function, because otherwise this just simple on-pressed function for the floating action button is going to get quite cluttered. So what we need to do is, because show Cupertino dialog and show alert show dialog have pretty much identical signatures, we're going to copy their signature really to kind of create a single interface which can work for both. This here, I'm specifying the return type of the function, and I've said future of type T. So this is using generics. That's why, so yeah, this uses alerts dialogs uses generics for their return type. That's how I can return any object here. And what I actually should have done is specified that delete is going to be a Boolean here. Oh, sorry, not T. Cool. So now here, the Dart compiler knows that, okay, this is going to be a bool. It's not going to be just something that I don't know about. And yeah, future is the equivalent to a task in C# or kind of like a promise in JavaScript. But yeah, so this is represents an asynchronous function, which is going to return something at some point. The async and await stuff essentially unwraps the object that the future is going to return, but only when it's ready. Cool. And we're going to call this show alert dialog. I then need to specify that there is going to be a generic. And now I'm just simply going to move this show Cupertino dialog method, sorry, function call, to here. So it and change from awaiting show Cupertino dialog to awaiting show alert dialog. Nothing is really changing here. I'm just calling show Cupertino dialog through another method. So you're going to see absolutely nothing different here. That's because really nothing's changing. But now what we want to do is do a check to see, is this app running on iOS or is it running on Android? And yeah, that's because in a in a Flutter app, it's using the same code, but you don't want, showing a Cupertino dialog on Android is going to look really out of place, whereas showing a material looking dialog on iOS wouldn't look as out of place. This is a scenario where you would actually want the platform variant. So there's a very simple way to check what platform you're running on. And you can do this by using platform, which is from the Dart.io library. If you're following along and you're using IntelliSense, make sure it automatically imports the Dart.io library and not the HTML one. And on the platform class, there's a load of static properties for doing different checks for which platform you're running on. So you can check, is this running on Windows? Is it running on Android, Fuchsia, iOS, Linux, or Mac? So yeah, you can really kind of drill down and start doing some really platform-specific UI or platform-specific stuff if you wanted to. What we're going to do here, and what we've done previously is only check whether it's running on iOS. And if it is running on iOS, then show the iOS looking dialog. Because realistically, material doesn't look out of place on Windows, Linux, Mac. It looks like it fits in with more places, whereas Cupertino only really looks like it should be shown on iOS. So now I'm just going to copy this and stick it anywhere else. This is something got become slightly big, but Luke is going to show you later how this can be broken down even more. We just need to get it into an even more broken down stage for Luke to break it down even more. So firstly, is iOS show Cupertino dialog? Otherwise, we just want to use the normal show dialog method. That's all I'm going to change for now. When I click this button, it is still showing up a Cupertino dialog using a very Cupertino, or sorry, a very iOS-like animation. I'm just going to make this false for now, so it will just call the show dialog. The only thing you'll notice is the way it animates in. It kind of just appears, but with a slight kind of background fade. Hopefully that comes through okay on screen share, but yeah, even me running it here and now, it's still very subtle, but it is showing it how Android would typically show it, which is cool. The only difference is we're using the kind of material animations using Cupertino UI components, and we can change that. That's all fine. We can just use a standard alerts dialog, which uses the material library. And we can change these Cupertino dialog actions to just use flat buttons. Flat button is another material UI component, and that works best for material looking alert dialogs. So now I'll click this floating action button, and you can see a very Android looking alert dialog. So anyone who's done any Android dev will recognize this and will be able to say, yeah, that looks like it matches the material library, which is cool. And these actions, they're doing the same thing. It's just showing ever so slightly different UI components in a ever so slightly different animation style. So I'm going to change that back. And yeah, that's all cool, but we've actually got some duplication here. We're using the same strings and pretty much the same actions, really. They're just wrapped in something slightly different. So we need to alter that before handing this over to Luke. So what we're going to do is we're going to create some properties on here. Sorry, not properties, parameters. So we're going to have a string for the title. We're going to have a string for the content, and that's to start with, sorry, content. And let's just start with that. We now need to have these passed into our show alerts dialog method call. So I'll just copy those before I get rid of them. Cool. Now here I can replace these with title. I'm using the Command D Visual Studio Code shortcut to select text, which is the same. Cool. So again, we're still not going to see any visual difference, but it's still functioning, which is really great. Now, the dialogue actions are an interesting one, and it's actually quite useful that Luke and I decided to use the scenario of alert dialogues to demonstrate switching between different platform UI components. And that's because this is actually probably one of the more awkward ones we found. And I'm going to show you how we get around it. But please note that actually this is a rare case. Usually you can just do, is the platform iOS? Cool, show this. If not, show that. And generally, they'll have the same signature, such as alert dialog has title and content. The only annoying thing here is that actions, there isn't a common alert dialog action class which we can use, and it fancies it up. But we're going to create that now just to wrap in our text and our onPressed method. So we're going to create a class. I'm just sticking this in a utils folder, just because we haven't done any other kind of folder structure. It's just going to go into utils for now. I'm going to call it alerts dialog action. And this class is dialog action. This class is going to have, it's going to represent, sorry, I can't type today. It's going to represent the title, sorry, text for our alerts dialog action. And it's also going to represent the callback, the function to call upon clicking. With this function though, we do actually want to pass in a build context just in case our callback does need to do any looking up the widget tree. In this example, we're not, but this is actually also a nice scenario of showing that you can specify different parameters and stuff. And call this on tapped. Cool. I'm now just going to use the command full stop shortcuts to create a constructor for the final fields. If you didn't see my talk last week and you haven't seen Dart classes before, rather than having to have a constructor body which assigns this .text to, this is how a typical class constructor in other languages look. But actually in Dart, you don't need a body. You can actually just say this .text and it, or this .untapped, and it creates them for you, which is really cool. Cool, so that's our alerts dialog action. So now we want to take in a list of alerts dialog actions. And there we go, that's found it and it's importing it for me. I'm just going to add a trailing comma here, just so it auto-formatting neatens it up a touch. And this is now complaining because I should be giving it an array. So let's just give it an empty array for now. Cool. So now we want to construct a Cupertino dialog action for each alert dialog action in this actions array. So let's go ahead and do that now. This is an array, and we're going to use a collection method which is found in loads of other languages called map. So on any collection type, such as a list, you can then call .map, and this then creates a function for us, which is our current action, and a method to return a different type. So it's kind of taking a class, for example, and you could take a list of integers, and for each item in that list, for each integer in that list, return the string variant of it instead. And that's what we're going to do here. We're going to return a widget here. That's a bad example. Sorry, that's got slightly unneat. So we're going to return a Cupertino dialog action, which has some text in. I'll leave that for now. This here is just complaining because the map returns a different type of collection. It returns an iterable instead of a list, so we just need to cast it at the end. And now that's fine, now that will start working. So cool, we can now start building up our Cupertino dialog action again. So this text here was actually represented by our action text, and the onPressed function, I called it onTapped, but that's okay. We're going to invoke it, but use, but we're going to pass in the current context which the dialog is being built with. The reason for this is that if where we create our action up here, we need to do any widget tree looking up, we want to have the most up-to-date context. Whereas over here, if we just use the current context, it's this one here. Whereas calling this with the context here, make sure it's up to date. this isn't something that we're going to be making use of in this example, so you won't notice anything not work. But yeah, this we found to work nicer and produce less unexpected behavior. Cool, right, I'm going to speed up a little bit now. I'm just going to do the exact same here for material. Can I copy that? I'm going to copy that. Only difference here is we want a flat button. Cool. So now we've kind of created a single kind of an intermediary class to create something which works for both Cupertino dialog actions and flat buttons. So now up here, we want to create our list of alert dialog actions. The text here is going to be no. Untapped is a function which takes a build context. Again, I've just alleviated the build context type. And this navigator.of context.pop with false. Need to remember that. And this one here. Oh, sorry, that should. Yeah, that's fine. And yes, delete. And that is going to return true. So now, again, you're not actually going to see anything different, but we have created a nice single method which we can use to show either a material looking widget or an iOS looking widget, which is really cool. So we'll click this and no still works, and so does yes. Then, but if we were actually running on Android, so I'm just going to say false here, it shows an Android looking one, which is really cool. So yeah, that is, there's a couple of other things that I just want to do to neaten this up. Because these show Cupertino dialog methods take named parameters, I want to change these parameters to all be named as well. So I can do that by wrapping curly braces around them. And also you can specify when they're required or not by using the @required annotation. But these are all going to be, these are all required really. So I'm just going to stick required on all of these. And yeah, that looks like it's broken our method call, but that's just because we need to make it more, we need to name stuff. So it now just looks a lot clearer as to where strings are actually going and where your actions are going. That needs to be called content. Cool. And the last thing we're going to do, because both of these methods require a current build context, this context we're getting actually it doesn't look obvious as to where it's coming from. That's because it's a member on the class that we're in. So that's why I can use this.context. But what would be better to do is pass in the explicit context that we do want to use. As such. So now our method, its signature requires an explicit parameter, and then it's got named parameters that we can use. So cool. So this method could now be moved out of this class if we wanted to, which is what we're going to do shortly. Well, in fact, it's what Luke is going to do now. But before I hand over to Luke to quickly demonstrate mixins and statefulness, does anyone have any questions about what I've just done, or anything they'd like me to go over, or any general Flutter questions at the moment? Cool. Silence is golden.
Yeah, I have a question.
Oh, yeah, go on, sorry.
So why is there so many different like Cupertino dialog? Do they have different functionality? Like, why not just have one that you like theme for your app? Do you know what I mean? Yeah,
sure. So there were, sorry, are you talking about the show Cupertino stuff or the?
Yeah, for example, the dialogs, the different dialogs. Why do you have like a show Cupertino dialog and another Android one? Why wouldn't you define something globally that just says, okay, are you in iOS? Show the Does that make sense?
Yeah, it does. So that's what we've kind of tried to achieve here, really, because Flutter doesn't do that. It is something that we have had to do ourselves. It would be useful if Flutter provided something like that straight out of the box, so it does just switch between them. But then that kind of it brings the control away from us and more to them. So it then kind of starts acting a bit more like how React or Xamarin Forms acts. So in Xamarin Forms, when you say button, you get an Android looking button and an iOS looking button. In Flutter, they don't really want they don't want that. They want you to be able to control every pixel on the screen, regardless of where it's shown. So, and it is just an annoying case that we do. It makes it clearer that the main differences here are actually the animations.
But why wouldn't they like make some sort of inheritance where you could have like an Uber dialogue and then you just subclass that?
Yeah, sure. You know, I don't actually know. It would probably make sense, but there are on pub.dev, there are adaptive. People have written code to. Okay, I might not use.
I'll interrupt there, Tom. The adaptive widgets are actually built into Flutter for many components, just not specifically dialogues.
Okay.
So there are a ton of widgets where you can specify, make this widget adaptive, and it will implicitly do it for you. But obviously Flutter does allow the developer the freedom to basically do what they want. So if for whatever reason you wanted an iOS dialog on Android, there's nothing stopping you.
Right.
Whereas if, you know, it did it all for you behind the scenes, it would kind of be, as Tom was sort of saying, it would take the control away from the developer.
Yeah.
And who knows what designers want? Designer might, you know, they might want that. So yeah, you never know.
All right. Cheers.
Yeah, good for that, Luke. There is somewhere on the Flutter site, I'm just trying to find it, where it does specify some things which they do actually kind of by default take away control for you. I'm just struggling to find that at the moment. But yeah, for example, things like the way a list scrolls, they, you know, on Android, you might expect to see a kind of a semicircle kind of fall down when you scroll to the top. But on iOS, they don't necessarily do that. A way I can actually quickly demonstrate that is Flutter platform, toggle platform. So what I've just done is I've told Flutter to actually now treat this app as if it's running on Android. So although I've still got platform.is here, while I'm debugging, the Flutter app now thinks it's running. Okay, maybe it doesn't that well. Okay, maybe this way of using it doesn't do that. But under the hood, this list view now acts as if it's on Android, so it scrolls like an Android. Whereas if I change it back to iOS, it scrolls like how it would on iOS. So yeah, some things they do, and there are some widgets which they do switch. I think switch. Yeah,
switch.adaptive
is one. So that changes based on the platform that you're on, and under the hood, actually, all that is doing is, so yeah, you can dive in and see the source code straight away, which is really cool. But under the hood, all that is doing is just switching as to whether, as to whether it's building a Cupertino switch or a where have they put that? Or building a material switch. So they are doing they can do some stuff, but that really they do want you to have the most control. So that's why we have had to do this. I hope that answers the question. It's definitely a Flutter decision that they want us to be in control of as much as possible.
All right, thanks a lot. Cheers.
Cool, that's okay. Cool, so I'll now hand over to Luke, where he's going to take this and make it so that we can, because yeah, right now we can only use this show alert dialog method on task screen. It wouldn't be usable over here, for example. So yeah, Luke's going to show us quickly how we can use Mixins to do this, and then also cover how we can click some of these to change content which is shown here, which is going to be cool. So yeah, Luke, if you're ready to take over, I'll stop sharing my screen.
Yeah, sure. Just give me 2 seconds. Let me know when you can see my screen.
Yep, I can see your screen. So
I'm just going to move you guys down to the bottom. Okay, so as Tom has alluded to, what I'm going to do is make it so that we can essentially reuse this, this adaptive alert dialog code wherever we want. What we're going to do is going to use Mixins. And what Mixins are is just a handy little way of using snippets of code, basically, across multiple classes. And what it means is like you can allow sort of plug and play code without sort of having to create subclasses of parents and worry about all that stuff, or even globals. So just to demonstrate this really quickly, I'm just going to dive into this utils folder that Tom's made, and I'm just going to create sort of my mixin. And what this mixin is going to do is it's just going to expose a public method that just does print something. And quite literally, this is just going to print something. So let's say we wanted to use this on this task screen that Tom's created. What I'm going to do is I'm just going to replace this sort of delete logic that he's just been doing. And we're going to want to call print something. So as you can see, because this isn't defined within this scope, it currently isn't available. It doesn't know what we're talking about. So what we can actually do is use the with keyword and bring in the mixin. And now all of a sudden it has access to this function just because it's public. And what that now means is whenever I click this, I can now see something printed to my console. So as you can imagine, this is something that we can take advantage of now to help remove redundant code and reduce the need for redundant code, in that this logic wouldn't have to be repeated on every screen that we want to use a dialog from. So what we're going to do is I'm just going to quickly delete my mixin. We'll call it something a bit more sensible. And we're going to create an alert dialog mixin. So it's going to be defined in exactly the same way. Sorry, alert dialog mixin. Cool. And then what this is going to contain is it's going to contain the code that Tom's just been writing. So we've got all of this handy method here that we can just strip out. And as you can see now, this is saying it doesn't know what we're talking about. But what we're going to do is we're going to strip that out. We're going to put it into this mixin, import all the things that it wants me to import. Sorry, 2 seconds. We want the dialog action. We want IO. We want some Cupertino. And then we're all good, as long as I pass in the build context. Cool. So what that now allows us to do is it will allow us to obviously reduce the size of this class massively by taking out all of this code that it doesn't necessarily need to have within this scope. And we've separated that now out to a mixin. So I can quite literally just say with alert dialog mixin, pass through the context. Apologies, that was just missing. And now we have all of that functionality back without needing the code within this scope. Mixins will only expose public functionality. So it will only expose this, this because it's public. So if, for example, we wanted to just sort of simplify this particular method a little bit and split it out, we can do so. So we can do a show Cupertino dialog, which will have the same signature as this. And we'll return this. And because this is prefixed with the underscore, that is Dart's way of saying it's private. There's no explicit keyword for private. It is just qualified by that. So you can see now I can do return this dot show Cupertino dialog, just sort of feed through the same parameters that we've been given. And what that will mean is that we can access this and it will work in exactly the same way, but from the place where you have imported the mixin, you will not be able to see the private method. I can see the public, but I can't see the private, which is obviously really useful if you want to obviously have perhaps more complex mixins and abstract away more code. So I'm just going to do this now. Well, I might as well copy this bit first. Essentially do the same thing. And we're just going to create a show material dialog, similar to the source code for the adaptive widget that Tom showed just a moment ago, which is going to return that. And then again, I'm just going to copy. Oops. Show material dialog. Cool. So that means now that this this show alert dialog is very simple. When we come to look at what it's doing, we'll go, okay, yeah, it's iOS, it's showing Cupertino, else it's showing this, and then we can obviously easily build upon that. And we don't have to worry about this class being cluttered with all of the private functionality that we've declared within that mixin. So as you can imagine, it makes obviously this code much more portable. It means that on the home screen, for example, if we wanted to have mixins, we could just do with alert dialog mixin, and that means we can, we can call alerts from here. We can do whatever we like. So that's just a really nice way, really, of making it super portable. But what we're going to actually do now is, as Tom alluded to, is we're going to actually allow the functionality to switch between the tabs. So right now, obviously, we do have these tabs available at the top, but clicking them doesn't necessarily do anything. So we're going to want to expand upon that. As Tom had mentioned earlier, we have this tab selector widget. And what this tab selector widget does is it renders these tab items in a row, but as I say, doesn't necessarily do anything with them. We're going to build upon this with by making this task screen itself stateful. So what stateful means, obviously it's already stateful, so we don't need to make it stateful, but we're going to make use of the fact it's stateful, I should say. What statefulness means is it means the widget itself can maintain and hold an internal state. And then that means if the widget, for example, takes user input, so here the input would be changing the tab, it would be able to rebuild itself based on those changes. So the idea here is once a user changes the tab, we would basically recognize that the tab had changed and we would change which list shows. So we'd switch between a live list, a done list, and a standby list. We have those already here, but as you can see, they're not being used. And that's because at the moment, all we're going to ever do is render this middle list. So what we're going to do to start that is we're going to keep track of a private int variable, which is going to just represent the current selected tab. And we're going to initialize that to be 0. So it will be live when we do that. And we're going to need a way of telling the tab selector what the current selected tab is. Cool. So it's going to be passed through current tab. You can't render a tab selector without tabs, so we're going to make both of these required. Cool. So now the tab selector will know, what tab has been selected because the task screen will be telling it. Obviously, at the moment, we're not doing anything with that, but what we can do is select this selected property to be true if this.currentTab is equal to the current index of the tab being rendered. And what that will do will mean that because we've set the index to be 0, and at index 0 is the text, is the tab that says live, live now has this nice little underscore. And what that means now is that the user can see that that is the current tab that they have active. We can build upon this further now by making the tab selector control which tab has been selected, if that makes sense. So if I was to click done on the tab selector, it would feed that back to the task screen and it would go, oh, my selected index has changed. And it would be able to then propagate that and it would change. In order to achieve that, we're going to create a function, which is going to be a callback that will return an int that we're just going to call on tab selected. Again, we're going to make that required. And what that will do is from the task screen, we're going to say when a new tab has been selected, so new tab index has been selected, set state, I'll get onto this in a second, this dot current selected tab is now equal to this new tab. And what set state does is it will mark the state as dirty and effectively mean that it's telling the widget that it needs to rebuild itself. It's saying, hey, you know, some property that's important to the rendering has changed. You know, I'd like to trigger a rebuild. And what this will mean is that then the tab selector itself will have a changed state. We're going to actually need to be able to change the tab. So we're just going to wrap this tab item in a gesture detector. And when the gesture detector has been tapped on tap, we are going to do this.onTabSelected with the index. Cool. So what that now means is it's going to be calling the callback. It will set the new index. It will be propagated through, and hopefully, as you can see there, it will change the tab that's selected. And that's all because this is being rebuilt every time. Obviously, it's not good on its own just to change the tab if it doesn't actually do anything. I mean, it's all well and good seeing these nice little underlines change, but it's not actually changing anything to do with the screen. So we're going to have to probably implement that as well. In order to achieve that, what we're going to do, instead of this rendering the done list every time, we're going to change it to render based on which tab has been selected. So I'm going to create a nice little function here. We're going to call it render active tab. And what it's going to do is going to switch on the current selected tab. And if it is tab 0, so on the case that tab 0 is the current selected tab, we want to return the live list because live is our first tab. Case 1 is the done list. And then case 2 is the standby list. Cool. So what that will now do is render the appropriate content depending on which tab has been selected, as long as we actually do call it from the main widget tree. The compiler, so is complaining here just because I've not set a default case. We know that there's no other situation here other than 0, 1, or 2. So we can just say, okay, I'm just going to return some text that just says, I will never show. I mean, it should never be shown, so it doesn't matter. But if somehow that ever happened, you get a nice little surprise. So what we're going to do here is we're going to render the active tab. And all it is each of the tabs have lists of different lengths. So you can see now that we're able to switch between the tabs, and it will switch between lists of different lengths. We can actually build on this because this is boring. You know, the widgets are just showing. I mean, there's nothing really, it's not really doing much. We can build on this by using a really, really cool feature of Flutter that I use all the time, which is implicit animations. Implicit animations are literally just that. They are animations that we don't really have to worry about how they work or how to do them. And the one in particular that we're going to use here is called animated switcher. And what animated switcher does is it allows for widgets that are changing their children. So in this case, we're changing the child of the widget, i.e. the tab. It allows for performing transitions for those changes. They have a nice little demo of this on the website. So you can see on the counter there, it's changing. We're going to make use of that here to switch between our tabs. It does require a duration, which I'm just going to set as, just so we can see it, it can be 2 seconds. But you can see now, when we switch tabs, there's this, I mean, it's really slow, so it probably doesn't look the best. But we've got a nice 2-second transition, which is a fade out and a fade in. But you know, who wants a fade? So what we're going to actually do is we're going to change that to something a bit more exciting, and we're going to use scale transitions. So we just have to override the transition builder, which will return the child and the current value of the animation. And we're just going to return a scale transition, where the scale value is whatever the current animation value is, and the child is the child. And that means now when we switch the tabs, look at that, we've got all sorts of animations going on, and it was within, you know, just a few lines of code, and we've been able to achieve that. Obviously, Flutter does support explicit animations. We can create our own animation controllers. We can create our own animations. We can do whatever we like. But just that it supports something as fundamental as this, like just out of the box, with very, very little code. It handles, you know, if you're changing states in between. And yeah, I just think that's something that's really cool. Another example of this sort of implicit animation stuff in action is the animated container. So if you have a container that's changing properties such as its shape, its size, its color, its content, it will basically implicitly animate all of these steps in between, which is, again, in such few lines of code, you'll be able to create things that I think, they look pretty cool. So what I'm actually going to do, so Tom can carry on, I'm just going to push this, and Tom will be able to pull that now and continue the presentation. So yeah, thanks for listening. And if you've got any questions, we'll maybe do it at the end or whenever.
Cool, cheers, Luke. Yeah, implicit animations is something which Flutter has, which added in, not ages ago, but long enough ago for people to make really good use of them. And yeah, they're something which the community asked for, and the Flutter team kind of said, yeah, sure, you know what, we'll add them. So yeah, you got some nice animations for free, which is cool. So I'm just trying to check out Luke's changes. What's going on here? Yeah, what you'll probably notice is that I've just deleted some files, and some files are about to reappear, but I still don't have to stop debugging, which is seriously really cool. So yeah, we've got Luke's code here, and I've got an Android emulator up here running as well now, just to demonstrate the differences. Hopefully maybe slightly more obvious. So it animates in, oh, wrong one. The dialogs animate in ever so slightly differently, and animate out ever so slightly differently as well. But this is using the exact same code, but just showing something ever so slightly different, which is cool. Oops. I forgot to handle a case in that. I'll make sure that's fixed before I commit it later. But cool. The last thing I want to cover in this is passing data between screens. Because right now we've just got some hard-coded stuff coming through, which isn't so nice. So I'm going to show you in 7 minutes how to achieve that. And it's quite simple to do. I'm just going to pass through a very simple string, but this can be any object. Actually, let's tell you what, let's pass through a to-do object. I will move it to a different file because I've remembered I'll need it in 2 different places. And this to-do is going to have a title and a subtitle. I won't worry about the sub-tasks or the avatars for now. This is enough to demonstrate the concept. Cool, so we're on our home screen and we're in this gesture detector, which is saying on tap, push the route called task to the navigation stack. So when I click that, this is what is being done. Push named actually has a named parameter which we can use called arguments, and that can be any object. Any objects we want to pass through, we can pass through. So we can pass through a to-do here, and we'll give it a title. We'll call it Tom's to-do. Commit code at end of talk. Cool, so we've passed an argument through to the root, but now at what point do we want to access that argument? For testability, we want the to-do to be passed in to, as an argument to our task screen. So that way this screen could be independently tested. So we'll say up here that we want a to-do, and create a constructor for it. And so yeah, what we now want to do is start referencing properties on this to-do method, to-do property. If you see though, where we're actually building up our UI is in a different class to the class which the to-do object is on. But these two classes are so tightly linked. That's why it's actually normal to see two different classes in a Dart file for Flutter, but only when it's the screen, stateful widget, and its corresponding state. That's the only time. But we can, and I've just realized that's not set up to be the nicest way. So that's now in header. We're gonna have to pass it through twice, but that's okay. So this was something I ever so slightly forgot to do beforehand. But we need to pass through some other stuff to the header. And the header wants these as parameters. So I've just used a keyboard shortcut to do that. But now I can say this dot title for the string and this dot subtitle. Cool. There will start to be some errors because it's, so yeah, this Android simulator, which was on that screen, it's tried to hot reload, but there isn't actually any data there. So we need to pass through a title and a subtitle to our header from our screen. I've done that, but it's just using an empty one. If I use one here, it now passes through. Cool, but we actually want to pass through the title and subtitle of the to-do. So the way we can do that is this class, which is a state object, it can access properties on its corresponding widget. So we can do this dot widget dot to-do. So we can now access the current to-do, which is relevant. And I'll change this here, this dot widget dot to-do dot subtitle. Cool. Now the moment I've saved this is going to break because we still haven't done the last little bit of linking up. It's saying that title is called on null. So it's recognizing that null hasn't actually been created yet. So yeah, there's a tiny little bit more plumbing that we need to do. We have passed an argument to the navigator to pass through to the root, but then the root doesn't need to use it if it doesn't want to. The screen wants it. So now, therefore, we just need to specify, we now need to hand it in to our screen from where we've declared our roots. So yeah, back on our material app with named roots, we have a string and a method which returns the corresponding screen, but we now need to inject our to-do in here. And the way we can do that, we can find out the arguments that are being passed used for the current root. And it's a one-liner which I'm just gonna use and then explain. Modal root of Cool. Modal root of context. So this finds the current modal root which is in the tree. Modal root is a nominal name, but it's finding the current root which is showing another screen. Sorry, let me describe that a different way. It's finding the settings. It's finding what the navigator has been told to do. So pass something to another screen. And we can see loads of settings on this root. So settings has things like the name of the root that would correspond to /task here. But we can also access the arguments and pass those straight through to the task screen. So that way we can independently test task screen in widget tests if we wanted to, because we can just pass it in without needing to depend on anything else up the widget tree. And yeah, I'll now demonstrate that has worked. So when we click on any of these, we will see, to be honest, the same 2D passed through, but nonetheless, it's being passed through. There are Tom's to do, commit to code, that's end of talk. And that's how you pass arguments to screens. So if this was actually loading proper to-dos from the database, it can pass through the correct to-do, which is cool. And that brings to an end everything that we wanted to cover in this talk. So yeah, we've done a little bit on platform-specific UI. We've done a little bit around alert dialogs and then how we can share code using Mixins. Touched on statefulness and how we can flip between, how we can change state. Then Luke's also demonstrated some really cool animations. If that was slightly faster, that would look even cooler. Reminds me quite a lot of WoW.js, this example. But yeah, there's loads of other cool ones. Sorry, the errors you're seeing here are just because I've not restarted the Android simulator. But yeah, the iPhone 8 is running fine. So yeah, I hope that's been relatively easy to follow. I know we've covered a lot and kind of focusing on a few different concepts here and there. But yeah, I know it's just gone 8:30, but did anyone have any questions that they wanted to ask?
I think, hi, thank you very much. That was great. I particularly liked the handover. That was smooth with the git push and pull in between. That was added bonus features there.
Yeah.
So it looks like Michael, unperturbed by the fact that you were able to launch it in an Android emulator, now wants to see it in a web version. Is that possible?
Is that possible? Is that possible? Let's see. Go on then. This is possible. Let me just stop debugging and stop debugging that one. Yes, this is possible. So as I mentioned last week, web support is on the beta version of Flutter, which I am on, because I wanted to demonstrate, oh gosh, no, not all. So I wanted to demonstrate that last week. And yeah, I had a slight inkling some people might ask. Yeah, I run this on the web, and this will compile the Dart codes to JavaScript. That was actually originally what Dart was used for. It was used for Angular. It was as a strongly typed language for Angular way back in the day. If that gave anyone shivers hearing the word Angular.
Stop saying it.
Sorry. Flutter for web. But yeah, so it compiles it all down to JavaScript so that it can run on Chrome. So yeah, it's.
I learned. I thought it compiled down to WASM.
It doesn't.
Oh.
No, it doesn't. It's definitely. Why does that not look right?
Because it's the web.
Because you've not added any yet, Tom.
Thank you, Luke. Thank you, Luke.
Right.
Yeah, that's it. The fear.
It's working too well.
Yeah. So and yeah, click on that. Commit code at end of Tom's talk. Flip between here. Wow.
The animations even work. That's epic.
Yeah. I did just notice that the dialogue didn't work. Oh yeah, that's why. So for web, that's something I actually completely forgot about. Mainly because web isn't in production yet, so we haven't been using it in production settings. But web has an ever so slightly different way you check for whether it's running on web. You have to check if
K is web.
Yeah, that's a K.
I think it's K is
web. And this is a compile time constant. So what this means is the Dart compiler uses tree shaking. So if it notices a compile time constant anywhere in the code, and that is as part of an if statement, if that condition isn't true, it won't bother including that compiled code. So here, if K is web, this determines at compile time whether it's going to be running on the web or not. If it isn't, then any code here won't be included. But if it is, I can then say else, then do this block. This block won't actually be used. So that's a cool thing for tree shaking. For web, we probably, it would look better with a material dialog. So let's see that happen. Yeah, it's still in beta. So hot restart essentially does a refresh, but doesn't necessarily keep control of everything. So please bear in mind, beta, it still isn't all too bad. So I'm now going to press that, and it's now going to show up an alert dialog, which is cool. If I go back, which it hasn't done. Remember, guys, beta. If I change this to show a Cupertino dialog, once this refreshes, I'm not sure if that did refresh it the right way. Well, it really stuck now. Yeah, great. Live demos.
Did you say it was a beta?
But yeah.
Yeah.
Okay. Beta, definitely beta. Now it's going to show a Cupertino looking dialog area, and it comes in with a Cupertino animation. But yeah, so full beta, it is still pretty good. In this example, we haven't necessarily done things which make it work better on web. But if you notice, this up here /task, that is actually the name of the route we've specified here. So it can do some, it does work somewhat well when you build your apps in a way that does that. Work with, routing up here. So deep linking stuff works. So cool, yeah.
I think Philip had a question.
Yeah, go for it.
Yeah. So I got a bit lost when it got into all creating classes and stuff like that. Am I going to need to up my game in terms of what C# and stuff I know before diving into this? And if so, where would you suggest I start doing that?
Do you want to learn some C# or do you want to learn some Dart?
The second one?
The second one. The second one is the right answer. So yeah. Dart is very similar to things like C# and they've got some nice animations here. It is quite similar to C# and Java. So yeah, to be honest, Philip, yeah, you may as well jump straight to learning Dart. And dart.dev is the website for the Dart language. If you head over to the docs, you've got this language tool section, and that just has the fundamentals for how to use Dart. It's quite useful to just kind of scroll down, and then where you see code samples, read the bit of detail around that you need to worry about. There's then also up here, try Dart. There's something called DartPad, and this is something which is actually kind of cool, which I kind of wish I showed last week, but if you're still around, you'll find this cool. So DartPad lets you run some Dart code in the web. And yeah, there's loads of different examples you can do. So yeah, you can, if you don't have a Dart environment set up, Philip, you can, practice your Dart code here.
Right.
So it does functions and stuff, classes, which is cool.
Right, yeah, classes.
So yeah, that's cool. Now, it doesn't, where's the cool one? Where's the cool one?
Where's the cool one?
Yeah, well, there's a cool
boring ones. I want the cool one.
DartPad with Flutter, please. Here we are. You can, with DartPad, you can use Flutter. Where are you? Let's do counter. You don't even need to install anything to start using Flutter. That's how damn cool it is. You can just use DartPad. So to get to that, I searched DartPad Flutter. Huh. And here you go. You can start running it. It's the exact same app that we get out of the box. If we change this here to pressed, you don't get hot reload. You get hot restart, and you have to click run. So you won't maintain state when making changes, but just for playing around with it, how damn cool is that? That is really cool. So yeah, that did change. They also have a few other examples up here. Downsides, it's all in one file, but if you just want to play around, it's fine. So implicit animations, here's a whole load of implicit animations. Okay, you ready? You ready? Click a disk. Ooh, ooh, sweep around. So that's really cool. And this is all Flutter. This is all stuff that, you know, a year ago, you'd have to, you know, copy this code into Visual Studio Code, run it on one of your simulators or devices. But now you can just play around with it in the browser, which is really cool. They've got some other ones. Sunflower, you can control how many seeds of the sunflower you've got. You can play around with draggables as well. So I want to drag that and it bounces back. Yeah, so that's really cool. If for any reason the barrier to entry of, you know, not having a PC that can, I don't know, run Flutter, or you're having trouble with the setup, even though the setup is actually probably still one of the easier SDKs to get set up, I find. If that's still a deterrent, then just play around in the browser. So yeah, it's really cool. So yeah, and to answer your question, the Dart docs and the Dart pad, or Flutter Dart pad. So yeah.
Those are cool. Those are cool. Kev has also popped in CodePen that apparently Flutter. Sorry.
CodePen,
A startup that CodePen now supports Flutter as well. I was going to mention like the CodePen version of. Yeah, nice.
Yeah, it's really cool. Yeah, that's something that yeah, they announced support for that a month ago now.
Too long ago.
Yeah. But yeah. So,
Chris Darnbirch, as a front-end web developer, is curious about the HTML output from Flutter Web and whether or not it's, I'm imagining, semantic. He's cautioning it seems like a dangerous approach for the web.
yep, sure. I can completely understand those concerns. I do and don't want to show this to you. I don't want to show it to you because web developers will look at it and think, what the earth is going on? But then also ask yourself, should this matter? If semantics such as you know, SEO works, if it works like that, so bearing in mind, you'd probably actually use Flutter for web for, you know, a progressive web app where you wouldn't actually go and look at the source code anyway. But because I'm here, I will show this to you. Wash your eyes of this. But yeah, it uses loads of custom DOM elements, and you can go in quite deep. It does some quite funky stuff with how it renders different stuff. So let's take a look at, if we take a look, yeah, I think I had this problem last time, but the text is actually oh no, it has changed now. No, yeah, it is, yeah. It does use a p tag for the text with inline styling, yes, fine. But
no nav elements for the tab bar or anything like that.
No, so it's
low on accessibility.
It's
in beta.
It is in beta, and for things like accessibility, there are actually a load of accessibility widgets that you can use with Flutter. So make your app accessible. It depends what kind of accessibility you're after. So the semantics one, if we wrapped the entire nav bar, tab bar in a semantics widget, this will, it even has a video describing it to you. This then kind of highlights, if we wrapped this tab bar in a semantics widget, that will now work for screen readers. We can then break it down to wrapping the individual tab items in a semantics widget, and that would then work for screen readers as well. So while it doesn't use all of the kind of, let's call it native web and DOM elements, actually, you know what? I don't want to say that because it could well do under the hood. It could well do under the hood. But it does. That is something that they have been concerned about, and it's something that they have put effort into working. The semantic stuff definitely works on Android and iOS. By the time they release, you know, a stable version of Flutter for web, I imagine it would be in there. I'd be surprised if it wasn't in there actually. But yeah, they do have support for that, for stuff like that. Cool.
Awesome, and that's, yeah, both horrified and also awesome at the same time. There's semantic widgets. They were speaking about search engines and stuff in the docs, so it does look like they're kind of geared up to the HTML side of things.
Cool. Yeah, great. Yeah, that's good. So yeah, Flutter for web is still actually in an incredibly stable state, even though it is beta. But yeah, it is really cool, and it's really promising for the write once, run everywhere, have control of all of the pixels kind of thing. So yeah, it's cool.
There was one other question that I missed actually. Lloyd, the benefit of using roots over creating a new instance of the widget in the push itself. So I'm assuming that's got something to do with caching, potentially in the state of the widget.
So what that question I have a feeling we'll be referring to, and do speak up, Lloyd, if not. So there's a couple of different ways that you can navigate between screens. We've used this method called push named, but there's another one called navigator dots of. You can push kind of. I kind of refer to these as on-the-fly routes, and this is kind of that's the best way to describe a route. A route describes the transition between a navigatable a screen or an overlay, and you can kind of specify the screen that you want to go to from this, the exact class from the screen that you're currently in. So here this is task screen, and then here you can pass a to-do in like that. Actually, just to make it a bit more readable. Cool. So do speak up if this isn't what you're referring to, Lloyd.
No, that's exactly it. Yeah.
Exactly it. Cool. So yeah, that's a very good question. And actually, the way I started off when I was learning Flutter, I used this way. I created routes on the fly, as it were. But actually, when it then comes to separations of concern, I've actually got a diagram which describes this, I think, fairly well. Named routes. So this is from an all-day workshop that I did back in November of last year. So yeah, if anyone is on the call who attended that, this will look familiar to you. So imagine you've got two screens, screen A and screen B. When you press this button on screen A to navigate to screen B, on the fly routes is essentially telling to the navigator, I want to go to screen B. I know all about this class. I know how it's constructed it. I've got the arguments that it needs as well. So here's all of the information you need, just kind of do this action. And that's all, in small apps where you're not necessarily passing around dependencies, for example, repositories or services, that kind of stuff. You could get away with using stuff like this when you just want to pass, for example, a to-do to another screen. But when you want to pass through repositories and services and this kind of stuff, say screen B needed the, I don't know, say it needed some kind of, say it needed a service or dependency that screen A didn't. If you're using on the fly routes, screen A needs to kind of get them as well in order to pass them through to screen B. So then you've got unnecessary dependencies in screen A, and there's also the whole thing of screen A needs to know all about screen B. So there isn't a very clear-cut separation of concern. Whereas named routes tell the navigator, hey, I want to go to something that I only know as screen B, whatever that is. Can you go and find out, how it's constructed and construct it and take me there, please? So navigator looks up to the material app widget, which is where we specified our routes, and kind of says, oh, cool, yeah, so material app knows how this is generated. It has its dependencies. So here we are, it's created, I'll use this to create one for you and take you there. So the benefits of that is that, say we did have some kind of services. So we had some kind of repositories for actually, yeah, put it my service. And then I'm not going to do an in-depth example here. So we had my service. You would quite typically, oh, that should have done that. You would typically do any kind of setup of services that you might need in your main method, just in case you needed to do any asynchronous setting up in here. And you then kind of, there's different ways you can store dependencies. But to be honest, in a very basic app, and in early days, storing a dependency on here like this and passing it through would be okay. Cool. That way, if task screen did need my service as well, it can pass through the appropriate instance. So that's fine here. However, back on task screen, sorry, home screen would also need to therefore it would need to know about the class task screen. It would then also need to be able to go and get any services it needs. And there are ways you can do that, but it just makes the separations of concern a lot clearer when screens only just kind of know the name of the screens, not how they are constructed or their strong type. Does that answer your question?
Yeah, that makes really good sense. Good example, a good demo. Dependency injection is quite an interesting one in this. Obviously, coming from a C# background, kind of interfaces and whatnot. But
yeah,
I'd be really interested in how it works in the world, really. Yeah,
so that's something quite big, which Luke and myself have really tried. Well, firstly, when we started working together 6-7 months ago, the kind of solutions we had were okay, but since then we've worked out some really great solutions. And actually, yeah, Luke has done quite a lot of research into working out really clean ways of passing dependencies around. Because yeah, in C# and some other languages, things like reflection are really prominent, and you can use reflection for instantiating classes just by knowing an interface that it's mapped to. Whereas in Flutter, firstly, Dart does have reflection as well, but Flutter doesn't support it, and the reason for that is a performance reason, because reflection in any language is slow compared to knowing types. When you're having to look up types and class signatures, method signatures, etc., that is a slow operation in the grand scheme of things. So when Flutter is still trying to achieve that 60 FPS and 120 FPS on devices that have 120 Hz screens, that slowdown could be prominent if they allowed reflection from the get-go, and then people were starting to build libraries and add to the SDK using reflection. So that's why that's not in there. But there are some other. It is definitely an incredibly advanced topic, but there's a useful library. And actually, Luke, maybe you're better to touch on injectable, because you've used it a lot more and you've done a lot more kind of research into it. But
I mean,
it's kind of the idea of a service locator, which is like a static singleton. But if I said static singleton to a C# developer, you would kind of cringe and be like, no. But yeah, Luke, do you want to just quickly explain how injectable?
Yeah. So as Tom sort of alluded to there, it exposes like a static singleton that you can use basically wherever. Injectable is essentially a little wrapper around another package called Getit, which is something that myself and Tom had basically written our own manual way of injecting things using Getit. And what it essentially means is you configure a sort of startup of your app. You basically configure Getit by calling a sort of configure method. And when you register, so when you create a implementation of some interface, so if you create iService A and then implement it as service A, you register service A with an injectable as an implementation of iService A. And that means anywhere where you use the static instance of the service locator, you can just go service locator.get me the implementation for iService A. And that means as well that obviously when it comes to testing and whatever, all of that's mockable because you can implement them and you can just register mock services and whatnot. But for what I found, and through a lot of trial and error, it has been the simplest and most just the easiest way to support dependency injection. So when I'll sort of expand on that as well. When you wanted, for example, to use service A or iService A as far as the thing that's using it is concerned, you tag it as injectable. You'll tag the view model block, whatever you want, as injectable. You'll declare an instance in the constructor and you'll say, I expect an instance of iService A, and it will just do it for you. So you use Getit to also retrieve the instance of the view model and it will just handle all of that for you. You don't have to do get me this view model and also give it the instances via the dependency injector. It will literally just handle that for you. So as far as you're concerned, it's just going to be available when you need it, whether that be through testing or through obviously real world implementation. But yeah, highly recommend. I'm one of those 82 likes on that package because I very highly recommend injectable. So yeah.
Cool. Yeah.
But I'd say it's a very advanced topic. It's something obviously when you come to actually doing production level Flutter applications, you're going to need. So yeah, I typically use it with sort of like a DDD principle when I'm actually making apps. So yeah.
Cool. Yeah. Cheers for that, Luke. So just to add to that, it does use annotations to marry this all up, and typically in another language like C#, you can inspect the annotations at runtime. In a Flutter scenario, you can't. So actually these annotations just highlight to injectable that it can generate code for you. So before you start running your app, you will you'll run a quick command line tool here, which will go and find all of those annotations for you and create the code to kind of do that magicking up and that dependency injection and passing around for you. So it's taken us a while to get to this stage and find that this works well, but this does work well, and this is very advanced, and this is like, yeah, there's probably a lot more to Flutter that you'd probably want to know it ins and outs of before you get to this stage. But yeah, that's how we've ended up doing what C# developers think of in dependency injection. This is where we've got to. Again, I hope that answers your question.
That was really good, really interesting. Thank you very much.
Cool. No problem.
It's fascinating also to hear that Lloyd, you're working, or potentially Greg's is working with Flutter and building apps in it as we speak.
Yeah, exactly. There was a kiosk trial up in Scotland where it was actually in production and used for a number of weeks before, obviously, the current circumstances came along. But I was just doing the services behind the scenes, but working with the guys that have written the Flutter behind that kiosk. It's really, really sharp, and it looks fantastic. It works exceptionally well. The reviews of the public using it are fantastic. So yeah, we're using it for future development, which I can't say anything about at the moment.
Sure. Well, thanks for sharing that much.
Yeah.
It's good to hear.
Yeah. It's really cool to hear. I mean, on the Flutter website, you can see a showcase which has loads of examples of high-profile apps which are using it. So Google Ads is one, and the Stadia mobile app is using it. Parts of the Alibaba app is using it. Philips Hue, interestingly, as well. I only found this out recently, but Philips Hue have actually done quite a lot of open source stuff for Flutter around Bluetooth, which is really cool. Then the eBay Motors app is all written in Flutter as well. So when high-profile names are using it, and Lloyd, you kind of said it does lend itself to really fantastic performance and experiences, and it is a really powerful tool to use. So
another one that you guys might be familiar with is an app that I developed, which was for Naked Wines, who are obviously based in Norwich. It was me and one other guy who developed that. So the Naked Wines app, if any of you have that, is actually a Flutter app as well. So yeah.
Awesome. Well, that was really, 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 really interesting. Thank you both for taking us through that. Like I say, the really nice, slick handover and very well prepared. Thank you very much. I've prepared a quick email that was with any resources that were mentioned as we went along, and there's links to the source code, links to both Tom and Luke as well, and Earthware, of course. So if you want to, well, I was about to say contract these two fine gentlemen to build your next Flutter app, by all means get in contact. Links on the email. Thanks to everyone for joining us. There will be a version of this going up on YouTube, like I say, as soon as I can work out how to use video editing software. But until then, perhaps see you next week for the data science, and enjoy your Flutter experiments.
Yeah, cool. Yeah.
Hey guys.
Yeah, thank you very much, everyone, for coming along again. And hope you've learned something. Feel free to reach out to us on Twitter, LinkedIn. Very happy to talk Flutter. It's cool. Cheers.
Cool. See you later. Bye.
Thanks, guys. Cheers, everyone.
Bye.
Thanks.
Thank you.
Bye.